Okay, we're going to go over some examples from 7.1. Our first example, find the critical value z sub alpha divided by 2 corresponding to the given confidence level. So we'll do 6. So for a confidence level of 99%, then alpha over 2 is the area to the right of the z-score that is symmetrically marking off an area of 0.99 under the standard normal distribution. So altogether, this shaded area is 0.99. So z sub alpha 2 is the z-score such that all the area to the right of that number is half of 1%. So 0.99 is going to leave 0.01 here. Well, it's going to leave 0.01 altogether from both tails. So half of 0.01 would be 0.005. Well, we can simply go to StatCrunch calculators, normal, go to the between setting, and then type in an area of 0.99, hit compute, and then we get the z-score for the left and the z-score for the right. So we want the rightmost z-score, 2.5758. So 2.5758. Okay, this next problem, blue M&Ms. So express the confidence interval 0.270 plus or minus 0.073 in the form of the sample proportion is between the estimated sample proportion minus the error and the estimated sample proportion plus the error. So that's the estimated sample proportion, and that's the error. So we want P to be sandwiched in between 0.270 plus the error, 0.073 on the right, and then on the left 0.270 minus 0.073. So if we do that arithmetic, then we get the sample is between 0.197 on the left and 0.343 on the right. In this next example, we want to find the best point estimate of the population proportion P, identify the value of the margin of error E, construct a confidence interval, and then interpret that. So we have a study, medical malpractice study of 1,228 randomly selected medical malpractice lawsuits, and it was found that 856 of them were dropped or dismissed. So construct a 95% confidence interval for the proportion of malpractice lawsuits that are dropped or dismissed. Okay, so that's the amount dropped or dismissed is this 856. And this 1,228, that's the total. That's our N. So N is equal to 1,228. And then we can call X, number of successes, 856. Confidence interval is 95%. So we can go to StatCrunch. And what we want to do is click on the Stat tab and then go to Proportion Stats, one sample with summary. So the number of successes in this case would be the dropped lawsuits. So that was 856. The number of observation was the total number of lawsuits. So 1,228. Then click on confidence interval, and it's already at 0.95, which is a 95% confidence interval. And then hit compute. So it gives us our sample proportion, and it gives us the left and right limits. So part A, find the best point estimate of the population proportion P. Well, P is going to be equal to this 0.6, that's the sample proportion from our confidence interval summary, so 0.697. B, identify the value of the margin of error. So the error is equal to the upper limit minus the lower limit divided by 2. So going back to StatCrunch, our upper limit is 0.7227. And then subtract the lower limit, 0.6713. Then divide by 2. So let me write this here. We get 0.0514. Divided by 2. So 0.0257. Now we want to construct a confidence interval. So we have P is less than, well, P is greater than the lower limit. Lower limit is 0.671. And the upper limit is 0.7227, so we'll round that to 0.723. So what does this mean? It means that we are 95% confident that P, this 0.697, is in this range here. Well, that the actual proportion of dismissed medical malpractice lawsuits are between 67% and 72. So 95% sure or 95% confident that the actual number of dismissed lawsuits was greater than 67.1% and less than 72.3%. Next example, fast food accuracy. So in this study, Burger King had 264 accurate orders and 54 that were not accurate. So construct a 99% confidence interval estimate of the percentage of orders that are not accurate. So there were 54 that were not accurate. So we'll set X at 54. That's the number of successes. Now N is not this 264. We have to keep in mind that it's the accurate orders plus the non-accurate orders that give us the total number of trials. So we have 264 plus 54. So our N is 318. So go to StatCrunch, and it's stat proportion stats, one sample with summary, and the number of successes 54, number of observations or trials 318. Click on confidence interval for the sample proportion and change that to 0.99 for a confidence interval of 99%. Then compute. Right? So we can be sure that the population sample proportion, or the proportion of non-accurate orders, is between 0.115 and 0.224. So P is greater than 0.115. I'll round that to 6, and less than 0.2240. Or P is greater than 11.56%, less than 22.40%. Now we're given a confidence interval for the Wendy's non-accurate orders. So the proportion of non-accurate orders is between 6.2% and 15.9% for Wendy's. So I'll put a subscript of BK here, and then in green I'll write P sub W for Wendy's. So the proportion of non-accurate Wendy's orders, we can be 99% sure, is greater than 6.2% non-accurate and less than 15.9%. But notice there's overlap here. So it may be that Burger King and Wendy's have the same amount of non-accurate orders. So it's too close to call. Okay, this example is about astrology. A sociologist plans to conduct a survey to estimate the percentage of adults who believe in astrology. How many people must be surveyed if we want a confidence level of 99% and a margin of error of 4 percentage points? Okay, so recall that, well, for the first part, if nothing is known and we need to estimate the number of surveys we have to collect, we want to use this formula. N is equal to the critical value corresponding to this confidence level squared, and then just multiplied by the number 0.25 when nothing is known, and then divide by the error squared. All right. So confidence level of 99% corresponds to a critical value of, well, you can go and look that up with your normal calculator or from your notes, but recall that it's 2.5758. All right, that's the rounding we use. Now, an error of 4 percentage points, you don't want to leave it as a percent. So E is 4%. To do the calculation, you want it as a decimal. So 0.04. So we have 2.5758 squared times 0.25 divided by 0.04 squared. And that works out to 1036.6. And we want to round up to the nearest integer. So 1037 to be sure that we make the correct estimate. Okay. So in order to get a confidence level of 99% on adults who believe in astrology with a margin of error of 4%, then you would need to go and survey 1037. Now suppose it's known that 26% of respondents, 26% of adults do believe in astrology. So what you need to use in that case is the formula. N equals the critical value for that confidence interval desired squared. And then you want the probability of success times the probability of failure, which is just the complement of success, 1 minus p, and divided by the error squared. So it's the same confidence level, 99%. So our critical value is again 2.5758 squared. But p is 26%, so 0.26. So we get 0.26 here. And then q, complement of p, 1 minus 0.26 is going to be 0.74. And then divide by the same error as a decimal, so 0.04 squared. And we crunch that out, we get something a little bit less than 798, so round it to 798. And that that concludes the examples for 7.1.